All right, let's go over MDX. These are my notes. I've taken these notes with the Microsoft documentation and lots of training videos. So this is basically an amalgamation of what I've learned. Let's see. MDX stands for Multidimensional Expressions. It is the language of analysis services queries. Okay, so why would you use MDX? Well, SQL is meant for 2D rows and columns, in other words, tables, while MDX is meant for many more dimensions, which is what you end up with when you're using cubes, which are basically a way of modeling a data warehouse. Data warehouse, you typically have more than 2 dimensions, more than 2 fact tables against your data tables, and those MDX results are called cell sets instead of a result set. Typically, you will flatten these multidimensional queries into a 2-dimensional data set so that you can read them, but you can use more than 2D, more than a 2-dimensional cell set to create drill-down reports. Typically, your results read a lot like a pivot table. You've got dimensions on the outside of the pivot table, and you have your measures on the inside of the pivot table. Okay, vocabulary, dimensions. These are your cube dimensions, which are built off your data warehouse dimensions. So they're a reflection of your data warehouse dimensions, but they're not exactly the same thing. Once you start using your dimensions with a cube, they really become more of a grouping of attributes of your measures. Okay, so the measures are the inside of your cube, basically. You can think of kind of the dimensions as the outside of the cube and the measures as the inside of the cube. The measures are, of course, aggregations that are built off of your facts, such as you might have a fact which is product sales amount, and you might take a sum of that. So that equation is a measure. So all measures are some sort of aggregation of some particular fact. So the granularity is always down to a single fact with a single aggregation. It does not have to be a sum, but you will have a single aggregation against a single fact column. And that is a measure. And you cannot access your facts below this level, which is kind of strange. You might be thinking, like when you're building a report, you might be thinking in terms of things like product sales amount, but you really have to think of terms of the sum, the aggregation of those facts. You do not look at individual facts with your measures. Okay, so measure groups. Your measures can be grouped into folders which are related. So that's a way of showing the user or someone coming in behind you which measures are related. But these groups serve no other purpose and do not affect the way that you will reference the measure in a query. Measures dimension. The group of measures can be referred to as a particular dimension, as its own dimension. This is kind of confusing because you don't really think of the measures and the facts as being part of a dimension. But in the cube, they kind of work like dimensions. The cube dimensions and the measure dimension, the one dimension that holds all of your measures, acts a lot like just another dimension when you are writing MDX queries. So it's often called your measures dimension. I find that confusing. I like to think of just measures as your measures, not your measures dimension, but it is something you will run into when you're reading documentation, that you will see people mentioning the measures dimension. And they're just talking about basically the group of measures. Member. A member is a single measure or dimension. So that's kind of confusing. When somebody says a member, that doesn't tell you whether they're talking about a measure or a dimension. It just means they're talking about this part of the cube, a single part of the cube. So it's just a way of referencing a particular part of the cube. You have to take what they're referencing as whether or not it's a member or a dimension. The default member. The default member can only be a measure, so that's part of the confusion here. A member can be a dimension or a measure, but when you're talking about the default member, you're only talking about a measure. One of the measures can be picked as the default measure, which is called the default member. And that's only significant if you write a query that doesn't explicitly name a measure, which is very, very strange idea if you're coming from the SQL world. In the SQL world, of course, you would name exactly which columns you're trying to aggregate. But in MDX, you can just use the default one. So you don't have to put a measure in your query, and it will just automatically query against whichever measure you picked as the default member. Okay, attribute. A member can be further broken down into attributes. A single part of a member, such as a hierarchy level, is an attribute. Okay, an attribute hierarchy. All attributes of a member are arranged into hierarchies, which is kind of confusing. That basically everything is a hierarchy in a cube, even if you haven't assigned a hierarchy. Now, that's what a user-defined hierarchy. If you actually build a hierarchy, like if you build a product category hierarchy or a geography hierarchy where you're going from country to city to that sort of leveling, you would have, that's a user hierarchy. But even without user hierarchies, every single attribute of a cube is a hierarchy. Okay, the all member. When you have a hierarchy, you can reference the all member, which is a way of saying, don't give me the list of members of that hierarchy. In other words, don't give me all the states in that country, just aggregate all the states together into one value. And that's when you use the all member to reference that, to say that you want that sort of an aggregation. You don't want to spit out all of the members of a level in hierarchy. You want them all aggregated together. So you would use the all member. Let's see. In MDX, you can have comments in your code. You can use the dash dash from SQL, or you can use the slash slash, and you can use the slash star slash star slash to do a multi-line. Those are single line, and this is multi-line. Okay, so when you're referencing parts of a cube, here we have a cube. So the sides of each edge of the cube you can think of as a dimension. And this is a very simple cube where we only have 3 dimensions. We have geography, product, and time. And you need to understand an important concept, which is the tuple and the set. A tuple is a particular cube here in the cube, a particular subcube of the cube. So it's a particular intersection. That's a better way of saying it. So here, this green cube is the 2002 sales for meat in California. So here's 2002, here's meat, and here's California. So this green cube cell right here would be a tuple. Now and then this is another example of another tuple, but a set would be like if we're going to take this entire group here, like if I say 2003, if I want all the data from 2003, that is now a set, because now that's a whole bunch of, that's a set of tuples. So all the data for 2003, that would be like a set. Or if I give me all the data from 2002 and 2003, that would be another set. So there's this idea of sets and tuples, and that's important because when you're writing your query, when you're doing a set, it needs to be in round brackets, and when you're doing a tuple, you need to be in round brackets. And when you're doing sets, you need to be in these curly brackets or braces. And we'll get into that later, of course, when we start writing queries. Okay, I already mentioned this, how dimensions and hierarchies, each attribute is treated as its own hierarchy. Typically, there's also an all. The dimension might also included in multi-level hierarchies. Let's see. When you're referencing, see here's those brackets, and then this is just basically a very basic select statement here for an MDX query. But what this is showing is if you want to reference an actual value in a dimension, you put this ampersand in front of it. So the ampersand says I want the particular records for this year. So I don't want just like the generic date dimension data. I want a particular set of years here. So if you're going off of a key value, you have to put this ampersand in, and we'll get into that. That's kind of jumping ahead. So the basics of a query, that's a basic query. So let's look at that a little more. You have the select clause, which sets up which data you're going to put on the columns, which one you're going to put on the rows, thinking in terms of like a pivot table. In your pivot table, you have columns and then you have rows. And you're setting up which ones you want to be on the columns and which ones you want to be on the rows. And so those could be dimensions here and dimensions here. And then the where clause is where your data, your measures are. So this is a dimension versus a dimension. And then inside the dimension, we're going to aggregate a particular measure. So your measure would go here. And then the from clause is just the name of your cube. So just real easy. And in SQL, your from clause is often very complicated because that's where your tables are, and there can be multiple tables, multiple joins. You can end up with subqueries and all that. But in MDX, the from clause is usually just the name of the table. I mean the cube. And you're not going to have more than one cube typically. Let's see. So let's go into. We've already talked a lot about members and hierarchies and attributes. Let's look at that with some examples here. So here you can actually see the tree. This is the geography dimension, and you can see it's broken out into several members, but you can see like the geography here, this is a user-defined hierarchy. So the rest of these are attribute hierarchies. So you can see country has members, and then it comes down here, and so you have country, and then you have country, and then you have the members of the country, or the attributes. And so even though this is not a user-defined hierarchy, it's still a hierarchy. So you can see we still say geography is the dimension, and then country is the hierarchy, and then we want country. So it's always dimension, hierarchy, attribute. So you can see, even though this is not a user-defined dimension, it's still a dimension. So all members of a dimension are a hierarchy, because you always use this hierarchy three-part structure to identify which dimension you're using. And then you have this axis that's saying, you want it on the columns. The axis 0 is the same thing as saying on columns. And the reason you can, but this kind of yeah, let's not talk about that right now. Let's talk about that later. I was going to start talking about axes versus dimensions and rows, but no, let's talk about multidimensional later. Okay, so that's with children. So here you can go geography country and then say children, and that's like this. And so if I just say country, I'm going to get all of the countries. Or I could step back to the country hierarchy. So I'm saying geography country hierarchy. So this one right here, and then I can say children. And that'll do the same thing as just saying country.country. That'll give you all of the countries. So now you can also, if I come down to the geography, the user geography defined hierarchy, if I say geography hierarchy, country level here, then I'll get that same thing. And so this is basically 4 different ways to skin the same cat. I get the same results here, whether I do it this way, this way, this way, or this way, whether I come up here and use the country here, or whether I come down here and use the country, geography, then say children, instead of saying .country, I still get, these are 4 different ways to still get a list of all the countries. But you'll notice if I say geography country and then stop, then I'll get this all member here. So that what I could have also said .all here. And then when you go, so this is geography country, so that's geography country, and then I stopped. And then this is geography. So geography, then geography is the hierarchy, and then nothing. That's the same thing as saying all. So that gives us that all geographies. So you can see it gets confusing because there's a lot of different ways to skin a cat. And I didn't even list them all here because I didn't show the .all versions. If this is basically taking the .all as the default here. So this part, you really have to get your head around how to, because this is the basis of writing your queries. You have to define your dimensions in your queries, and this is the basics for defining your dimensions in your queries. Okay, we saw how the children works. Now there's also members. Members would give you this list, just like children gave you this list, but it would also include the all. You would see the all geographies in the list as well. So which is basically like your grand total. So if you want all of the children plus the grand total, then you use members. Okay. Now if you want to not look at, say, Canada, but you like, say you just want to look at Canada, then you would put ampersand Canada or ampersand United States. If you want to look at just a particular one of the children, then you would call out that child if you're using the key, you would use the ampersand. If you're using a name value, then you don't use the ampersand. So that's a little confusing. And that you can do it. You can name a particular one with and without the ampersand. The difference is if you're using the key column, then you need to use the ampersand. Okay, so this is very, very basic. Understanding this is very, very. This is the foundation basically of MDX, is understanding that everything is a hierarchy when you're trying to name it. You're trying to refer to it basically in your query. Okay. Let's see, these are just basically some more examples. So this is dimension hierarchy member. If you just say this, and then if you have the or, so you can do this. See, like number 1 is the key for bikes. Bikes, the key column, which is basically the category key. The category key that responds to bikes is number 1. So if I want the bikes, if I want the bike's dimension, use that as one of my dimensions, then I can either use the name column and refer to like there's a column for name, and for bikes, bikes appears there. But then you've got a key column where the number 1 is the ID for that. Then if you want all the categories, you would say children, and then if you want all the children and the all member, you use members. Okay, now if you want to come up to the parent, if you want to select the parent, then you just say .parent. So if you have gone all the way down to the state level and then you say parent, well, then you're going to get the country. If this is a state, we've gone all the way down to Texas, we say parent, then you're going to get United States. We come all the way down to Quebec, you say parent, you get Canada. So that's just how to use the parent function. Okay, this is an empty query, which is kind of wanted to show this because this is something very different compared to SQL. When you have a select from your cube, and then from, of course, is the cube. So all we're doing is saying select from our cube. You still get a value here, and that value here is your default member. We talked about that, which is basically a default measure. And so if the default measure is basically the sum of sales, then this number represents all of the sales in the entire cube, without looking at date ranges, without looking at products, without looking at any of that, just every single sale all summed together. That's that value. So, and that brings up a very important part of MDX, is that MDX is, if you don't explicitly state what year you're querying, what group of years you're querying against, or what group of products you're querying against, or what group of customers you're querying against, then it assumes you want all of them. So if I did take this query and I added in a range of years, then it would recalculate that sum of sales based on that range of years. But it would still assume all customers, all regions, all of those things are assumed. So that's a big difference between SQL and MDX, is this assumption that you want everything if you don't tell the query engine that you don't want everything. Well, SQL's kind of the other way around. You have to explicitly tell SQL what you want, or it will give you nothing. So it's sort of the opposite of SQL in that respect, and that's something you really have to get your head around trying to learn MDX. Okay, here's how you do a between. So we have a select, and then on axis 1, we haven't put anything inside the brackets. So on axis 1, we're not going to put anything, and that's the columns. So here's our results. So you can see these are the rows, because this is axis 1. So what we're going to do is we're going to put countries. We have a geography hierarchy, countries, Australia, between, and then we have this colon here, which says between, and then we have Germany. So everything, so Australia, Germany, and everything in between is going to be on the rows, because that's axis 1 from AdventureWorks Cube. So we get Australia down to Germany as our rows. And then exclude is the same exact format, except you use the minus. So here we're going to say country, children, so that would normally give us a list of all the countries, but we're going to say minus Germany, minus France, and that is going to give us a list of all the countries minus Germany and France. Okay, let's take a break here, and we'll come back. We'll split this into parts. So this is the end of part 1. Okay, let's continue with my notes on MDX query language. Let's continue on with how joins are handled in MDX. Now, to do that, I think it's best to compare a T-SQL join to an MDX join. So here we have a very typical kind of SQL statement where we're doing an aggregation. We've got sales territory, we've got a product, and we've got the sales amount. And what we want to do is we want to aggregate the sales amount for the particular country and the particular product. So you would just say select the sales territory, the product, and then sum the value we want to aggregate. And you would need to join these tables together because, of course, the territory and the product and the sales information are in separate tables, because this is not a cube. This is a relational table. This is a relational database where everything is normalized, like a production database. And in our where clause, we would pick out the particular product, and our group by would allow us to aggregate over that sum. We would group by the 2 fields that we're not aggregating in this clause, and that would allow us to aggregate these values for these lookup values. Basically, these would be lookup values. Now, in the MDX query, you'll notice the from clause, all we have is the name of the cube. And that's because all of these tables become dimensions and measures in our cube, and they're all related. We have a star schema, and the star schema is connected by one-to-many relationships. So an MDX query assumes that those relationships are there. So that's what your query is built on top of, the design of your cube. So it's very important to get the design of your cube correct so that you can actually query on it, because the query is built on a lot of things, especially these relationships between the dimensions and the measures. So we just assume that these joins are here, so we don't have to make them. But again, so here's our sales amount. So there's the sales amount, and that is put on axis 0, which is columns. So you can see that's put on this column. And then we have on axis 1, which is put on rows, we put what we're aggregating against. So these are not columns, they're rows. So each of the values is looking like a row. So this is like you can think about this more, instead of this being a table, you can think about this more as a pivot table, where we have these values being aggregated, and we're rotating these 2 dimensions around this data. So we talked a little bit about curly brackets and round brackets before, where we had tuples and we had sets. And you can see here's the we have a group of tuples and we have the grouping of sets for each of the axes. Now, in this particular case, it's very simple. We have only 2 dimensions here forming a tuple, and then our set, we only have this one tuple. So we don't really need the curly brackets here, but it's considered good practice to go ahead and put the brackets in anyway. Up here on this axis, we only have the one measure inside of the tuple, so we don't need these brackets or these brackets because we just have the one measure. But again, it's good practice to do that. That's the standard to show the markup. So the other thing to note here is we see nulls here where we didn't have sales in certain territories. We don't have nulls here. That's because these are inner joins. So we're only going to return rows that have values. The joins in your cube, they act more as an outer join. So if you want to get rid of the nulls, you have to explicitly use functions to remove the nulls, and we'll do that later. Another thing, now next I wanted to talk about rules, but we'll go ahead and use this code to talk about that. You cannot repeat a hierarchy inside a tuple. And so these brackets act a lot like the group by clause, but just as in the group by clause, we don't repeat the same information. You're not going to want to repeat the same information inside a tuple either. You're going to want a different hierarchy. And then for the sets, you would repeat it, and because for the sets, we don't have an example of that here. We don't have multiple dimensions in our sets, but the sets would fall under the same columns and rows, so you would want those values to line up. Otherwise, the data wouldn't make sense. So for the sets, you must use the same hierarchies. There's a way to get around that, and we'll talk about that later. But for the most part, it's a rock-solid rule. These cannot be the same, and these, and for the tuples, and then for the sets, they must be the same hierarchy. And hierarchy basically means the first 2 values of the address to the dimension here. Okay, so calculation within and context. So now if you wanted to do a calculation, you can't just put the calculation inside your tuple. MDX doesn't allow that. You have to create a member. So here we're creating a member, and in this case the member is named %profit. So that could have been any text we wanted right there. That's just an alias for this equation. And then we use that alias inside our select statement. So, and you can define any number of these before you hit the select statement. So we could have had many of these members defined and then use them down here in our select statement. But in this case, we only have one defined. So we have our calculation here, and the calculation is typically made up of our measures and some mathematical functions. So now we throw that on the column. So you can see here the %profit is on the column here. Now here we have an example of a set. So we have the curly brackets, and we have 2 different measures, but you can see they're in the same hierarchy. They're both the product hierarchy. And we're doing 2 particular products. We're doing bikes and clothing, and we're referencing those by the ID. So bikes has an ID of 1, and clothing has an ID of 2. And then, of course, the from is the name of our cube. So the other thing we want to talk about here is go ahead and understand the concept of context. If you're familiar with DAX query language, it's a very similar concept to the context concept in DAX. Typically, when you do create a calculated measure, it's going to be something like this, where you take the regular measures and you add, subtract, multiply them together to come up with a new calculated measure. So in a calculated measure, you would just have the equation. And then if you wanted to calculate that equation relative to your dimensions, that's your context. So the select statement here is providing the context for how we want to actually do the calculations here. And normally that would actually be done by your users. If they have some sort of a slice and dice tool, like an Excel pivot table that they've opened your cube up into, then they would be selecting your calculated measure, and then they would be selecting the dimensions that would act as the context for your calculated measure. So it's very important to take that into account when you're designing your measures and you're designing your dimensions, so that they all play nice together, because if they don't play nice together, you need to handle that so that your users don't end up with erroneous results or incorrect results or confusing results. So okay, so context, it's a very important thing to understand, and we'll talk more about that. But if you end up not understanding context by the end of all this, you definitely need to get your head around it. It's a very important concept. Now, if you're not using a slice and dice tool, if you're, say, generating a report, then this would be the type, then these select statements are going to be what you're going to use for the backbone of your report. So you would have something like this to be the backbone of your report, where you would then go on to create some sort of chart or graph or just a table showing this information in a nice format using reporting services or some other reporting tool. So that's typically the way you write MDX. You either write a full-blown query like this as the backbone for a report, or you're just writing the calculation which will go into your calculated measure that will then be used in a slice and dice tool. Okay, forget about this union all stuff. That's not really correct. I was thinking really that this was a lot like a union all, but it's not. These separate lines do not get union together, but it is sort of like a union all in that they have to match up because they have to line up. These have to be of the same hierarchy so that these numbers still make sense. If these were different hierarchies, then these values would be coming from different calculations, and they wouldn't make sense. So that's why you're limited to using the same hierarchy inside a set. So that's here's an example of where we actually have three. But notice I purposely chose the same one to show how rigid that is. How whatever comma delimited list of hierarchies you put in here, it's going to show up out here. So you may want to repeat it and then do something with it or something like that. So let's see that here we're actually using, this shows sort of like our first example where we're creating a tuple here, and you can see here we have two different hierarchies, and so these are used together on the aggregation. So when you want to use different hierarchies, you think about it simply like this. If you need to use different hierarchies, you use the round brackets. If you're using the same hierarchies, then you use the curly brackets. You can think about it simply like that. It's a simple way to think about it. Now, if you need to do formatting, all you do is at the end of your measure, or at the end of, here's a calculated measure, or at the end of your hierarchy, you use this format string, and then you name the formatting that you need. And that's just an example of percent. And this is an example of a monetary currency type pattern here. Let's see. And then here is an IIF, which is acts like an if statement. So here in the calculation, your calculation doesn't just have to be mathematical, it can be logical. So we have an if statement. So if the percent profit is below 100, then we might say low, and then if it's above 100, we might say it's high. And then we're just going to output that high-low on the column. So we're saying on 0, which is on columns, we have A1, and A1 is just the name of our calculated measure here, our member really, our measure. And I used A1 to show, this can really be any name you want. It's whatever you want to use here. Count existing. So if you're actually wanting to count the number of values, you use this members. Remember, the members gets us the number of unique values within that hierarchy, and then you use the count. Let's see, and here's an example of doing a filter. So here with the filter, we've got the on columns and then comma. So it's after. So we have our set, and then we have the on columns, and then we put a comma, and then we put a filter statement. And the filter statement, we say what category we're filtering, and then we have the measure that we're filtering. So it's basically the context and the measure, and then and then we have some sort of a filtering statement. In this case, we're saying greater than a value. And here we can have, and this shows how we can also use ors and ands to further look at this. So here we're only taking values that are over this value or they're under this value. And this shows where you can put filters. You can put them all over the place. Let's zoom in a little bit here. You can put the filter basically at the end of each and every one of your hierarchies, and you can put it, and you can also have a having clause. We'll get to that, which you can use to do filtering. So the having clause comes at the end of your set, and then of course you can use a where clause, and the where clause can have filter statements at the end of each of your hierarchies, and then you can have a filter statement right out front that you put your sets inside of. And then there's range modifiers. We'll get to that later too. So there's a huge variety of places you can put filters, and it gets kind of confusing because you can't just put the filter anywhere you want. It really depends on when the calculation is being done, and you have to put it at the point that's feeding the next calculation. We'll talk about that more later, but it is kind of complicated as to where you put your filter. It's not that you have all these different ways to skin a cat. You have to put it in the right place sometimes. Sometimes you do have a choice, but a lot of times you have to put it in the right place. Okay, the where clause. You can use the where clause to set the measure if you don't state the measure in your query, thus overriding the default measure. So here's a case where we've got the date dimension on the columns, and we have a category dimension on the rows, so here we didn't state a measure, so if we didn't have this where clause, it would use the default measure. But we typically don't want the default measure, so you can use the where clause to override that default measure, and then that becomes what we're going to aggregate over. So this is a pivot table where we have the calendar years and the products, which are hitting these intersections where we're going to use our measure, which is order quantity. So these are calculated order quantities. Okay, limit the data to the year. So here we're going to use the where clause, but we're going to use it in a limiting fashion. So we've got on the columns we have the internet sales, which is a measure, and on the rows we have the category members. So you can see the category members, internet sales. Now if we we've overridden the default measure because we have a default measure, but we would get all of the years if the way it's written here, because we didn't say anything about the years. And remember, we get all of everything that we don't specify. So if we want to actually specify a particular year's data, we can do that in the where clause and state the year, and now we'll only get the data for this particular year. Okay, I think that's enough for this part. I'm going to stop here, and then we'll continue on in part 3. Okay, MDX part 3, going over my notes. Okay, you'll see a lot of nulls in a lot of these examples, because like I said before, the joins that are used behind the scenes in your MDX statements are open joins, outer joins. So you will return a lot of nulls for missing values. And you can get rid of those. But you don't call them nulls, you call them empty. They're not empty, they're null. They're not null, they're empty. And what you would do is you predicate before each of your sets, you say non-empty with a space, or if you're using tuples, the round brackets, you would say non-empty without the space. So it's kind of odd that there's two different ones, but there's one for tuples and there's one for sets. But that will remove the null values, the empty values here. It's the same as saying not null in SQL. Okay, now in SQL we have an order by, and then we'll usually say descending, ascending. In MDX it's a little different. You have an order, but then you don't say by, you just say order. So here you say order, and you put the order on, you predicate your tuple with it. So you put order right before your round bracket, and here we have two measures, and then you have a comma, and then you state inside the tuple, you state whether you want the descending or the ascending. And then notice there's a little b. There's a b that comes in front of it. You don't just put ascending, descending, you put b. And what b does is it says break the order that you're normally using, because if you'll notice, and up here it's alphabetical. We never said anything about making this alphabetical. It just automatically is. It assumes that you want to always order your data based on the alphabetical list of your columns and rows, which for reporting is pretty typical. But from the SQL Server world, it's very unusual. From the SQL Server world, if you don't put an order by, then it orders based on the index of the table, which is usually your key. So you'll get this somewhat random order based on the key, and that's usually not what you're looking for if you're going to be reporting. So then you put some sort of an order by that overrides that order if you need to output it to a report. But typically inside a SQL Server, you're not outputting data to a report. You're inserting rows and updating rows and checking rows and passing rows to the client and that sort of thing, and you don't care about order. So you don't use a lot of order by. But in MDX, we're often using this for reporting, and so it just defaults to ordering your headers for the rows and the columns alphabetically. But if you want to order by the data, then you have to break that, and that's what that B stands for. You put a B in front of your descending, ascending, and that will break the order. So in this case, you can see that the data has been ordered from greatest to lowest, which is descending. We've ordered the data descending, which has broken the order for our dimension headers out here. We're starting with west, which obviously is not alphabetical here. So so you don't use the order very often, and you have to be careful about it because it will break the order out here, and you have to decide, do you want the inner order or do you want the outer order? And often you want to stick with that outer order for reporting. Okay. Current member, previous member, next member. Okay. We've talked a lot about hierarchies, really, and the different functions you can use with them. Well, there's three more that you'll use quite often. One is the current member, previous member, and next member. Often you need to get the previous value or the next value when you're doing some sort of reporting in order to compare them. For example, if you want to show this month's sales versus last month's sales, or this year's sales versus last year's sales, then you need these functions here to pull the previous or next member. And the current member is often used to get you back to what you had, or as a documentation thing to show that this is the current member. So I'm going to go ahead and put it there. Okay, now let's talk about count, having, list items, divide. This is a whole bunch of things all in one. This is a kind of complicated query. Here we create a measure here where we're doing a count of the children of customers. So this is going to count our customers for the particular context. And then we have another measure where we are going to divide one member by another. So we're going to take the customer count and divide that by the count by this measure here. So now, and often, when you're doing a division, you want to make sure that your divisor is not 0. So here's how to do a select case where we're saying when this is greater than 0, then we can do it. Otherwise, we just return 0. And we're doing a formatting. We've seen formatting before. And then here we're doing a select, and here we've got 3 different things we're putting on the columns. So you can see we have 3 columns output, and they're all of the same hierarchy, which we've talked about before. That has to be the same hierarchy. So we're going to show the measures on the columns, and then we're going to show the state provinces. So we're doing this by state province in these calculations. As you can see, there was no context given up here. We're just talking customer children up here. But the context is being supplied by the rows here. And we have some filtering going on with the having clause. So this is also showing the having. So we have the customer base greater than or equal to 0.01. And we're throwing that on the rows. All right. This is just another example of a having clause here. Let me make that a little easier to see. Here again, now here you can see the having clause is being used up here on the first axis. So it doesn't have to be in the second axis. It just has to follow the set. You always have it at the end of the set. And here you can notice we're saying we're actually limiting the category. We're limiting the context. We're taking product category and we're saying not components and category, and where the category is not clothing. So we're going to have a context that includes all of the categories except for clothing and components. And here, well, we'll talk about these later. This is doing some more set theory here. Oh, and this shows how, I talked before where you can't just filter anywhere. And this is a good example of that. Let me again make it a little bigger. You've got 2 places you could have put the having clause here. We've got time, internet sales, internet order quantity. So here we've got those 2 measures, and that's on axis 0, and then we've got our dimension, which is on axis 1, which is the rows, and that's where we have our having clause where we're saying internet order quantity greater than 240. Now, our order quantity is up here, so you would have thought, well, I would be putting it up here, right? Well, this actually would get you an error. It won't work here. You have to put it here because this is actually feeding the context to this. So you have to be mindful of the fact that you have to filter based on where the context is coming from. These are getting their context from this, so this is where we have to put the having clause. Okay, now here's another example where we're doing the top count. Let me again make this a little bigger so we can see it. If you want the top values for a set, you use a function called top count, and you would put it takes several parameters. The first parameter is your context. So what we are doing here, we have on the columns, we're doing a reseller sales amount, which is a measure. So we've got a measure here, and then on the rows, we're going to use these cities. But we only want the top 5. So we've got our context, the number of them we want. So we're doing a top 5, and then we want to repeat the measure that we're filtering on. So we have to have the context and the measure inside the top count. But this is on the rows, but it's only going to return the context for this here, and it's going to use this internally. So it's kind of a strange function here in that you repeat the measure instead of just feeding the measure, unlike you saw before when we were doing the having clause. Notice here that it automatically breaks our order by. It did not do the standard order by the context. It ordered by the data, because it assumes, since we're doing a top, that you'll want to do that you'll want to see them in order by the data. Okay, now the bottom count basically works the other way. Let me get it a little bigger here. And you would think that, you know, why even bother showing this? Because it's pretty much the same thing. You've got to give your context, and you've got to repeat your measure. You've got to give the number, but there's a hidden kind of gotcha here. Typically, the bottom values are filled with zeros and nulls and things like that. So in order to keep your bottom 5 values from being zeros or nulls, we need to put a filter in here. So we have a filter use a filter context within the context parameter. So we have our same context, but we also introduce where this measure is greater than 1. So you can see it's really odd. There's so many places we could have filtered, but if you want to do this sort of filtering, we have to do it here at where the context is being defined. So that's typically where you put your filter. As you've seen before, it's kind of a pattern that's emerging here. Wherever the context is being defined, that's where you have to put your filter. Okay, so let's stop there and we'll continue on in the next part. All right, this is fourth video on MDX. Let's talk about how we can use MDX in analysis services and reporting services. What are we going to do with these queries that we're writing? So we're in SQL Server Management Studio, and I've written a decently complicated MDX query. Let's look at the results to get an idea of what we're doing here. Here's the sales amount. This is just our measure for sales, where it's just sum of the sales. And I've got a calculated measure up here that I've created in this script called previous year's sales. So all I'm doing is looking back at the previous year's sales month to month. So this is January's sales last year. This is January's sales this year. And then I have another calculated measure up here where I'm doing the percent change. And there's no way to really grab this value from this column, grab this value from this column like you can in Excel. I've got to actually, inside this, I've got to do the work of both of these. Well, basically, you just call these two functions inside this function. So it's not that bad. And then, but in our reporting tool, we're going to need something more than just these months here, because reporting services likes to order these things alphabetically. So I'm also have a function in here where I'm generating this month number. So, and that's just for ordering purposes. Okay, so it's not that big of a deal to do these. What we've got is we've got the previous year's function, and this is the most complicated of the functions because we have to use this parallel period, and that takes, the first parameter for that is what level in the date hierarchy are we talking about, and we're talking about year. And then the next parameter is how far forward or back do you want to go. We want to go back 1 year. And we also have another parameter here where we can put in a date, but if you leave that blank, then it's going to take the past in context, which is what we want. We want to pass in the context, so we're passing in the context to this. And this context needs to go to our measure, our sales amount measure, so we need to pack that together in a sum so that this context will get passed to our measure. Okay, and we have another calculated measure, which is the month number, and that is where we take the calendar hierarchy, and we get the current member from the context, and we say properties, and we say key 0, and that gives us our key, which in this case is the numbers 1 through 12, or the key column for our months. And then we have another calculated member, which is really mostly it's just the calculation of the percent change in the sales. We take the current sales and we subtract the previous year's sales, and we divide that by the previous year's sales in order to find the percent change. We've got a little more code here to check to make sure that our denominator is not 0, and if it is 0, then we would just say not available. So this makes it a little more user-friendly. And then we've got, and then this is basically our query. So we're going to, on the columns, we're going to put our calculated measures and our measure, and on the rows, we're going to put all the months, all members from our date hierarchy using month, and we use all members, and that'll spit out the months. Now, this is an interesting trick I learned from generating a query in analysis services. In the browser, you can click this button up here, and you can go from your data and go into design mode, and it'll actually show you the MDX behind that. And when I looked in here, I saw something curious. I noticed they had a from clause, and then they had another from clause. You can actually nest from clauses, and that actually came in handy here because I wanted to do this all members with it, but then I also wanted to set the date range. I only have a complete year's data for 2007, So I wanted to limit it to 2007. Well, when I tried to create a where clause for that, it threw an error saying you've already used that hierarchy, you can't use it again. What I did as a workaround for that is I used the between, which is a colon, and I just did between January and December for that year, and that worked fine. But then I saw this interesting way of nesting a select clause inside the from clause. So this is what kind of reminds me of SQL. You can embed another select statement inside your from clause. So I just wanted to demonstrate that, and it's a neat little workaround in case you need to reuse a hierarchy. You can get around this only use hierarchy once rule. So that's all there is to this code. But okay, now how do we use this? How do we use it for report services? How do we use it in our cube? Well, in our cube, what we would want to do is we would want to take one of our calculations and embed that in a cube calculation. If we come back in here and we look at our cube, we have this calculations tab. So we can take that code and we can embed it in a calculation. So for example, this percent change, we can take this code, but you see this code, well, if we use this code, it's going to depend on the previous year's sales. So we would have to also do that one. So let's do that. Let's get the previous year's sales because our code will depend on that. So we'll take previous year's sales and we'll create a new calculated member. So now we paste our code in here. So that's our code. And we come back here. We can get our name here. And we can paste that in here. So now that's how you would use this, and now it's available to anyone who's browsing the cube as one of our calculated members. So of course, to use that, we would have to rebuild. So we're going to rebuild, and good, and that worked. Okay, so now we can come back out to the browser, and we'll refresh. And now you can see previous year's sales is here for us to use. So we can do, so sales amount, that's current sales. And if we do previous year's sales, we can see there's previous year's sales. And if we come in here, we can see, look at those first two numbers, and we can see the first two numbers, so it's the same values. And then of course we would just cut and paste to bring the percent change in, and we would be able to use the percent change in here as well. And of course that means when we go into Excel, it's there to drag and drop in Excel. So this is how we would make our calculations available to people who use the cube directly, like people who use Excel and other tools that can connect directly to our cube and see our calculated measures. Okay, so what else can we do with our MDX query? Well, we can feed this data as it is to a report in reporting services and actually report on this data. Instead of just using bits and pieces of our query, we can use the whole thing, the output from the entire query. Okay, so how do we do that? I'm going to go back into data tools, and I've added a report project, and I've added an empty report, and I went ahead and added a data source, which is just a connection to our cube. And what we need to do now is add a data set, and that is where we put our MDX query. So I'm going to add a data set, and we want to use our existing connection, and then we go into Query Designer. And then we go into design mode, and in here we replace the stub MDX with our MDX, and we can get rid of these comments here, and we can actually run it here, and we can see that we get exactly the same output that we got over here in Management Studio. So that looks really good. Go ahead and hit OK. And now you can see here's all our fields. There's our month number and our sales amount and our percent change, previous year sales. So this all looks really good. But one thing I noticed, if you come in here and look at the data, if you go to fields, everything's coming in as a UDF. So that means that even our month number that I created just so we can do an ordering in the report is still coming in as text. So we're going to have to convert that. And we could do it right here, or we can do it in the report itself. Let's try doing it right here as a calculated field. We're going to just put month num, and we can use fields. We want the month number, and we want to convert that to a integer. So there we go, there. So that should convert it to an integer. So now we can just drop a chart. Let's just use a bar chart. Let's use a generic bar chart. And what we want to do is put our new month num down as the bottom of as what we're going to graph the data by. And then we need to add the data. Let's do our percent change. So now we can come back into this, and we see that the label is the number, and we want the actual month as the label. We don't need these groups, and the sorting is by that new month number that we just created. So that all looks pretty good. So let's do a preview. So here we can see, now we've got the months in the correct order because we're looking at that month num, and we can see our percentages came out good. So, but now we look at the data, we can see that it's still pretty random, and that makes sense, really, because this is the forest. This is all the products, all the customers, all the regions. So we probably have trends within the products, within the customers, within the regions, but because they're all overlapping in this data, we can't see them. So this data really needs to be broken out by region, broken out by customers, broken out by products, that sort of thing, and then we might be able to see some real trends. Of course, this is also dummy data. But anyway, I guess that's the end of my MDX tour. Any questions, leave below. Thank you very much.